Assalamu alaikum and welcome to this video. This video is a demonstration of the project by one of the IBA students, Sarmad Zafar, in the graduate course Machine Learning 1 in the MS Data Science program. So the topic of this project is to forecast the inflation rate in Pakistan and as well as nowcast the GDP growth. So we all know forecasting is basically done some time steps into the future, for example, for the next few months or for the next few weeks. And nowcasting is done in the very near future, like maybe for the next hour or maybe for the next minutes or something like that. So it's a shorter time interval in the very near future as compared to forecast. So what we are doing in this project is to basically use the data available online to forecast the inflation rates in Pakistan and also nowcast the GDP growth. So let's first browse through the report. So this is the topic that I've already told you about. So it's a requirement basically for the macroeconomic policy making, that you need to have very crucial information about the current state of the economy. And the people who are into the policy making business, obviously it's a huge burden on them to understand what's going to happen some time steps down the line, just to have an idea, obviously based on the past economic patterns and trends. And there are different indicators, like you have the GDP growth, inflation, unemployment rate, the trade deficit, exchange rate, etc. So all of them are indicators of the economy, but the ones that are dealt more closely are GDP and the inflation rate. So the inflation rate data is released on a monthly basis for most of the countries. It's known as CPI, Consumer Price Index, and it's released by Pakistan Bureau of Statistics in Pakistan on the first working day of each month. So this is easily downloadable. And as I said before, that it's a very important economic indicator, and the forecasting is even better in that case. Okay, so the next indicator is the GDP, and the GDP data is typically not available on a very frequent basis. It might be available at the end of the year or at the end of 1 quarter or 2 quarter, whereas in the case of Pakistan, it's available actually maybe after 1 year, and that also like 4 to 6 weeks after the year has finished. So it's a very low frequency data, and it's not possible for us to make so many assumptions regarding what has happened during the year. So typically we want a more drilled down version of what is happening regarding the GDP growth, like on a monthly basis or on a weekly basis. So what the policymakers and forecasters do, they make use of higher frequency data, such as they can use some survey based indicators like the PMIs, purchasing managers indices, that can give you an idea about the GDP growth with a higher frequency, obviously. But one of the things that we can do is we can use the Google Trends data, which can be used to construct this quarterly estimate of the GDP growth. So these are the workarounds that people are using to forecast the GDP growth at a very high frequency. So now this is what we stress in the case of machine learning or time series forecasting or even deep learning, that you need to have the background knowledge. So the student was working in actually in State Bank, in fact, and which is the bank with the highest authority in Pakistan, which makes all the policies for all the other banks. That's the State Bank. So although he did not have a degree in economics, but he's currently working in that cluster in State Bank. So that gives the knowledge. Plus, trainings and workshops are always important to get the knowledge of things which you don't have. For example, you can take some diploma or take some training attend some training or workshop. So he attended IMF macroeconomic forecasting, monetary policy analysis, and forecasting topics in the IMF workshop. Then a workshop in IBA in which there was introduction to machine learning for economists, and then bank defense training over big data. So that sets up an environment for working, and it creates a lot of understanding before actually work start on working something for which you don't have an official undergraduate or graduate degree. So these training workshops or diplomas are really helpful. And the data sources are not very hard to find. You got Bloomberg, IMF database, Google Trends, and they can give you lots and lots of data regarding the CPIs and the GDP with a higher frequency. Obviously, most of the people are now sticking with Python, but you can also use R or Stata or some other tool if you're feeling comfortable with that. The student also went through some research papers, and this develops a very good perspective. You know about the tools, you know about the data sources, you know what you're talking about and what you want to do. You understand the background of the things. You understand how the economy works, and then you read some of the research papers as well to understand that what the people are researching about in this domain. Obviously, you can see the topics here: nowcasting and forecasting with big data, a comparison of time series and machine learning models, tracking activity in real time with Google Trends, obviously. So all of these papers or blogs, you can say, are really important to develop the base before you can actually start working on a machine learning project. And obviously, you can go through the current market practices, to understand what's happening currently in the market. So here is a template, which is the business knowledge template. This is provided with the data that I give with this video. So this is the project detail that what you want to do. Got lots of features here. We have the time series data since January 1991 from different sources. These are the outputs of the workshop that the student took. So you can see what are the outcomes that you acquire, the knowledge that you acquire from the workshops, the knowledge from the research papers that the student went through. And oh, sorry about that. It's just yeah. So you can see here so for example, here we can see that in this nowcasting methodology, which employs innovative ML techniques to produce early estimates of GDP growth. So that can give you an idea of the algorithms that have been used. New methodologies in TS econometrics developed over the past 2 decades. So that will give you an idea of the research done with respect to time series forecasting for forecasting economic indicators. And similarly, in this paper, machine learning in central banking. So it basically tells the use of big data analytics and other things like nowcasting GDP and inflation, etc. Natural language processing, how you can use that to forecast or estimate economic indicators from the textual data which is available online. And you can also use these technologies in real time, for example, in the case of the COVID-19 pandemic, to estimate the impact, for example, of this pandemic on the economy. So I'm pretty sure that you can find hundreds of research papers on this topic now, because everyone wants to jump in on the bandwagon. But the concrete research, we need to identify the concrete research outputs, and we don't need to look at the number of publications that have been published. And in this paper, like comparison of univariate and multivariate time series models. So what happens is that when you read the papers, when you do workshops, when you read research papers and you read these Wikipedia articles, and you document everything here, like economic forecasting, how that is done, what are the basic algorithms, what are the basic techniques, what is the background, statistical methods, what are the most common ones, etc., etc. What's the time series, to understand the time series data for someone who does not have a computer science background. Something like this could be very useful. The tools, we have these 3 tools, but Tableau, basically Tableau can give you forecasting through exponential smoothing, I believe. But it's not very flexible. it does not give you a very flexible data pipeline like you have in Python. And Stata is not actually comparable with Python these days. The data sources, so we have documented the data sources here. So these are the details of the data that we have used in this project. So all of these data are available from different websites. The Bloomberg terminal, the Haver Analytics website, IMF database, and there are others like SBP, etc. So all of the data is here, so you can just follow them and download your own data sets. And so what are the international organizations and central banks? So what are the trends there in the European Central Bank, BIS, World Bank, OECD? So OECD weekly tracker of GDP growth provides a real-time high-frequency indicator of economic activity. So it's not something new. So they have implemented a tracker like maybe based on Google Trends or other, alternate indicators to forecast the GDP growth. Another thing is to make ex-ante estimates of the likely values of output, and big data can provide many potentially exciting opportunities, etc., etc. So NLP, machine learning, nowcasting. So it seems that this it's everywhere now. In the World Bank, the potential for big data transform government is vast. Big data is this, and it has a lot of positives that we can use. Federal Reserve USA are using machine learning to construct financial conditions index, and it's really not a big deal now. But we don't know how much or to what extent these models are being used in Pakistan, but there's a high chance that they are being used extensively in policy making. So then we also have this personal experience of Sarmad from his state bank job. Most of the work then includes analysis, policy making, impact assessment. So the point is that when you have a personal experience in a domain and you get all these data, then you absolutely know what to do. In fact, you know how to tackle the problem. Okay, so that's exactly what happens. So let's go back to the sheet. So now all of these things I've shown you the complete documentation of this, so you can go through the Excel sheet yourself. But what I will recommend is that whenever you have a machine learning problem, you first identify why you're doing it, and which is what is happening here in this page, and then you identify what people have done and what you know already about the problem. Once you have done all of these things very thoroughly, you have an idea about everything, and now you can just start working on the problem. So this is the monthly CPI data, which is released by Pakistan Bureau of Statistics. So it consists of these indicators. It consists of lots of indicators, in fact. So all of these can be predicted or forecasted separately. And we particularly focus on the CPI index. Sorry about that, just the CPI currently, but you can and the viewers can just they can build on this the Python worksheets or the notebooks to just make your formulate the problem according to your own desire or according to your own knowledge. So given all this data and business requirements, the problem is to forecast the inflation at some horizon, and the horizon that we have taken is 12 months. At the same time, the GDP nowcast, we have already talked about the fact that it's a low frequency data, so we need some sort of extra knowledge there. And that knowledge we have taken from the Google Trends, from which we use to construct a GDP tracker, like we saw also for World Bank or some other, some other bank. So the problem for forecasting the inflation rate, these are the algorithms that we went through. And these are all the like exponential smoothing, MA, AR, ARMA, ARIMA, SARIMAX, and LSTM. Obviously, this is the collection of all the possible time series forecasting models that you can use to forecast a time series. So you can see that better results are being obtained through ARIMA and the Serimax models, giving you better results as compared to exponential smoothing, which typically performs better than ARIMA. And LSTM in this case is 2.352, which is sort of incredible because LSTM has the power to remember your history more so than all of these algorithms. Probably it requires some sort of tuning because it's a multi it's an artificial neural network, so it requires lot of hyperparameter tuning, etc., etc. So maybe there was not much in there, but and it is also possible that the data was not that much complicated to require an LSTM, because when you use deep learning, you need to have complicated and data in large volumes. So if the pattern is pretty simple, so maybe LSTM is not going to give a good performance. But in my opinion, it could be because we have not tuned that much. Otherwise, you could get comparable accuracy or even better than ARIMA, but not that much, because you see already the root mean squared error, which is a very strict indicator of regression problems, is quite low. So that means the model is fitting quite well. As far as the problem of GDP forecast is concerned, so we treat that as a machine learning problem because we got different indicators from Google Trends and we use that to just forecast the GDP or predict the GDP. And in here, the better performance is being acquired through gradient boosting and adaptive boosting. So it's basically boosting forces every instance to learn by giving it more weight at each iteration. That's what it does. Like add a boost, and gradient boosting does that through following this stochastic gradient descent formula. And one of the extensions of gradient boosting is XGBoost, which does lots, which also combines this process with like several optimizations to make the process more less resource intensive, etc., etc. XGBoost is a accumulation of many different things, and that's why it shows very good performance over many different problems. So in this case, boosting seems to be winning here along with random forest, because both of these approaches, we all know, they are bagging and boosting the ensemble approaches. So they are supposed to perform better because of the fact that you are sampling different problems from the same problem, or you're forcing the weak learner to learn itself until you learn. But you can see some comparable accuracies from SPM as well, and to some extent even decision tree. Okay, so it's very hard to say, but seems to be obviously the mean absolute. If you look at the mean absolute error, so it seems that the bagging and boosting approaches are winning. So now let's turn our attention to um, the actual code so we can understand things better. Yeah, so here is the multivariate LSTM forecast model for the initial problem that's forecasting the inflation rate. So we import all of these, we ignore the warnings, we import the file. So you can get the file yourself from the Pakistan Bureau of Statistics website. You can get the latest file and try to do this yourself. So this is the series to supervised function, obviously, because we need to convert a time series to a supervised learning problem, which can be thought of as a regression problem. So you need to create different time steps like t minus 1, t minus 2, t minus 1, t. So you need to create a supervised learning problem through the shift operation. So it's something which is quite common in time series forecasting. And then you need to scale that in range either -1 to 1 or 0 to 1. Mostly people, I think they're doing from scaling from -1 to 1 so that all the columns remain homogeneous. But you can use 0 to 1 as well. So here is the scaled series. So we have scaled up to 20 or 19 variables. So there are 19 different time steps. So that's the scaling part. And we have these variables. So we just print them again. So these are shapes of the training and test sets. Obviously, then we just initialize the sequential model in, I think it's Keras that we're using. Yeah, we are using Keras. We introduce the LSTM. We give it the training data. We just the density of just the one output we want at the end, and the loss is mean absolute error. Atom is the optimizer, which is basically the best stochastic gradient descent method up to date. So many people are using Atom, just a recommended model right now. It might be having some extensions as well, but I'm not aware of those right now. And you can see that the loss is decreasing. This is the loss, which is decreasing all the time. So you can see here it's pretty simple. So it learns very quickly. And I don't think so this was even done on a GPU. So it's the data is pretty simple. So now you can use that to make a prediction, and you can see that it's it's quite aligned with the original one. So with some sort of trial and error over the LSTM configuration that you can define here. For example, you can add you can have two hidden layers. You can have dropout between the neurons of the hidden layers. You can have different activation functions, etc., etc. Okay. So there has been new tuning done, but still the performance is good and the convergence is done pretty quickly. Okay. And the same task when we go through the time series model, so we can import all of these in Python. So we now define a set of functions for file to data frame, the details of the data frame, the missing values and what to do with them, changing the column type of the column. There's sort of a template. So you want to change the type of a column. And this is, I think, you want to change the type of a numerical column, etc., etc. So and these are, I think, for the so for this function is doing lots of things for the numerical data. It's plotting the box plots, it's providing you the statistical summaries, and it's also giving you the Shapiro-Wilkinson normality test, etc., etc. Okay. So this is the same function which uses the shift to make a time series of supervised data, filling up the missing values of time series, etc., etc. Okay. So we have the CPI urban data, which we imported in the last file. So we have many features there. So these are the features that we can analyze. And in fact, for this LSTM file, so what we have done is that we have, in fact, we have created, first of all, we have created, we have done a shift, T-1 shift for each of the 19 variables that we have. That gives us like 38 or approximately 40 variables. And then we have actually used this data set to, so we use the information of the previous timestamp for all the indicators to predict the inflation, which is var1 right now at this point of time. So that's how the problem has been forecasted at each timestamp. So based on the data on the previous timestamp for all the indicators, we are using that to predict the CPI or the inflation at the next timestamp. Okay, so this is the input which goes. These are the 19 values that go as input to the LSTM, and this is what we want the LSTM to output. So that's the game, but the data is not that much. So it's here like 351 rows, and the testing are only 12 rows. So you can see here, still it has adapted pretty good. So yeah, just 12 rows, and it's just it just requires more data. I'm pretty sure LSTM will perform pretty good. In any case, for this one, which is we have seen these functions. Now we want to use these statistical stochastic methods. So these are the actual values that are there. The CPI is obviously the first variable here that we're interested in. So these are all the variables that we have already used here LSTM, but they were not specified. You can see the file here. So we got some missing values. Um, yeah, so I think CPI has 14 values. As CPI is a variable which needs to be forecasted. So there are no missing values in the data. And now we have the histogram. So you can browse through the histogram. Or we want to basically check for normality. So there's not a very strong skew in any of the columns. It's pretty okay. Obviously, it's all topsy-turvy in some places, but I think it remains more or less normal. So we can approximate that easily through a normal curve. This seems pretty skewed. This one also seems pretty okay. So you can see, but there are others. There are other tangible methods. So these are the box plots which are going to give you the same information as the histogram. So you can see the boxes. The box plot is pretty good shape. None of them is very constricted or very broad with a few outliers. So that means the data is pretty reliable. And we call in that function. This is the scatter plot. So all of these things show that it's so this is pretty much not predictable, which is the RES. REM is fine. This is also, it shows a linear trend. It can be approximated. TB and this are oil variable. So we can decide to, everyone is going to have his or her own method of dealing with these variables. So the variables which are not very convenient, they can be removed, who don't have any pattern, or you can also find out the correlation, etc. So this is just the scatter plot. And so these are the statistical details. If someone wants to analyze and make some conclusions, you can. And then we conduct these statistical tests. This is all output from the same function that we saw earlier on. And now we also plot it with respect to time. So we want to see whether the series are stationary or not. That's the primarily what we want to see. So all of these are pretty good time series. So we can look at the ones which is the CPI. The CPI is one. This is pretty much predictable, but it does not seem to be stationary. So it needs to be, it needs to get stationary through differencing or any other approach. So this is what we specify here. So through seasonal decomposition, we can know about that. So it's just this function which we call, and it shows you the trend and this is this is the seasonality, this is the noise, and one of them is this is the residual. So as you got four things here in the seasonal decomposition. So it's not written down here. I just forgot one thing. But typically, I think we have the cyclic trend. We also have the I think the seasonal pattern. We have the noise, and there's one more thing. So this the last one is the noise, in fact. So now whether we are, so we are plotting trend. Yeah, so we are plotting the trends. So this one, the first one is the trend. Then we have the seasonality, which is the data is pretty much seasonal, and then we also have the residual. So we're plotting three things. So the data is seasonal, the trend is linear or increasing linearly or exponentially. And then this is the noise, which is not white noise, in fact. As you can see, for all the series, the trend remains almost the same. I mean, the trend means that the trend for all the three graphs remains almost the same. So everything is seasonal. The trend of the noise also remains the same. So, I mean, they are all equal with respect to their data. And then we can conduct this Dickey-Fuller test to understand that which of the series which are stationary or not stationary. So it's a roundabout way of doing it. So it seems that none of the series is stationary here, which is obvious from the trend. So we can conduct the test. We can here we do the differencing, the first order differencing, and then conduct the test again. So we see that some of the series have become stationary. And we can do the double differencing as well to understand that now almost I think all of the series are now stationary after the double differencing method. That's what is written here. So now you can form the data frame with the stationary series. And this is the data frame that we have. So this is the stationary series which has been differenced twice, in fact. And so this here, the mean and the variance remains almost the same. So all of these are now examples of double difference time series. So now what remains is now we want to predict them. So obviously for the time series, we are looking first of all, after doing all of the above and catering for missing values, we are looking at autocorrelation plots and partial autocorrelation plots to determine the values for the ARIMA model parameters. So here you can see that there's a very high correlation existing between the different time lags, lots of them in fact, maybe up to 30 time lags. There's a very high correlation. But if the partial auto, if we remove the external factors, then it's just correlation with the previous lag. Here, this is for the CPI. For this one, this was also for the CPI. Okay, so this was for the series which has not been differenced, and this one is for the different series. So, so now you can see that the lag actually is lag 2 is pretty good, or lag 5 is good. We can use those values. And for the partial autocorrelation, there's a negative correlation due to the differencing factor, and we can go for lag 2, 3, 4, something like that. So now we just we just print these things to understand. So when you see the exponential smoothing, so you can use the exponential smoothing formula. So it's in the template, and what we want to see is the output of the model with all this additive trend and seasonal trend, and we're looking for this AIC score primarily, which is a more famous measure for the time series results. Here the AIC is pretty low, minus 362 with exponential smoothing. And now you can fit the model here, so you see it's fitting pretty well. Similarly, you can use ARIMA. Here the AIC is 563. So maybe we have gone through it again. So this is with moving average, it is 533, which is quite large. And with ARMA, it is 537. With ARIMA, it is minus 2142, which is the minimum as compared to even exponential smoothing. So with the AR or MA or ARMA, it's pretty high. But with AIC, it's the lowest with ARIMA. So that means it's a pretty good fit now. So here you can see. And with SARIMA, it is again of the same range. It's a pretty good fit. And it seems sort of strange. So multivariate, this LSTM model is, we have already seen how that is happening. But the ARIMA model is giving a very good forecast. But the series is, this is the plot of the residuals. So it has converged pretty quickly. So it's able to make a very good forecast here. The RMSE is simply that. It has learned quite good in a good way to forecast the data. These are quite a lot of years, so we just summed it up like this. And finally, what we have is task 2, which is the prediction of the GDP based on the indicators given by Google Trends. So here it's always better to define some functions which you can use throughout. So you can understand the intent of these functions, dropping a row, dropping a column, catering for missing values, details of the data frame, some visualizations that are important here, filling up the missing values, what to do with the numerical data, which we have already seen, and the same bar graphs for the categorical data, changing the column types, changing the column operations, and performing numerical operations to column values, deep copy, creating a copy, and applying labeling to the categories of the categorical column, doing a scatter plot, ANOVA test, t-test, a normality test, which is obviously the Shapiro test, correlation heat maps, and these are all the different machine learning algorithms which I've already shown you at the beginning of the video. So you can make use of this template, feature selection with the random forest feature selection, and other feature selection methods as well, class, addressing the class imbalance problem, etc., etc. So there seems to be much in this template which anybody can use. I'm just uploading that. So when you go for this Google trend and mobility data, so this is what you get. So you got all these factors on the mobility data, and what you want to do is to use them to make a prediction for the quarterly GDP data. Okay, so this is the quarterly GDP data that we have here, and there do not seem to be any missing values here or in the other file as well, the initial file. So you just GDPQ, you just analyze that the box plot is pretty good, the scatter plot is good, and the dates, they'll show you the dates, how the GDP is varying with respect to dates. If you decompose that from a seasonal perspective, so this is again the trend, this is the seasonality, the data is seasonal, and this is the noise, so it's not white noise. So now what we do is that so if we start from here, so this is the GDP data, the box plot is pretty good, the scatter is good, and you can just see it across the date as well. So if you see the trend here, so it's pretty much the same. There's a linear increasing trend. We have the seasonal data. We don't have white noise. So we can just convert it to quarterly data by looking at 4 time periods. So you can see that the 4 time periods are used to estimate the first value, and then followed up by the other one. So is the percentage change, every quarter. That's what we need to understand. So it's the percentage change which is brought out on a quarterly basis. Yeah, so in this way, like for example, this is the for the last 4 periods. So this is the percentage change that has occurred across these four time periods. So in fact, across these 4 periods, this is the change that has occurred, and then across these 4 time periods, this is the change that has occurred, and so on and so forth. So we can drop the missing values from this to have this data set, and when we plot this, so it's a new time series, in fact, which we want to predict. And you see the trend is also changed. The seasonality is pretty fine. The residual graph is also pretty good. So we don't have any wrangling here. So we just have these, data. So we plot these, but eventually we have to merge it. So we convert these to quarters, quarter 1, quarter 2. We label it that way. And then we just merge this with the original data set. So when you merge it, after doing some sort of analysis, you can see that now this is merged with the original data set. So now we have the GDP with all the other economic indicators. So what we can do, we are now ready to start the forecast process. We can have the correlation heat map to find out the relationship of the correlation of the other variables with respect to GDP, and from these we can select many variables. So we just shorten it up and see what are the good variables here that we can identify. So this is basically a manual process. It's very difficult to analyze such a complicated heat map in this way. You need some function basically to make some conclusion by outputting the values by default. We can't study this chart in this way or even in this way by compromising on the variables. So we can have some sort of function which can just single out the values and give it to us. So this is something of an error probably, which anybody can correct. So we have economic crisis and recession. So we have all these the different time series that we have in the data. We just plot those to understand what is happening. And now we now start with the fact that we want to predict the GDP with different algorithms. So this is the multi-layer perceptron. This is the LSTM. MLP regressor. So I just there is a lot lots MLP is not performing well. Let's try some of the techniques. So it's not a very good. So that you see the prediction here is worse. It's not a very good prediction, and there's a lot of difference between train and test. So it's probably because the data is not that much. So we need to follow some other algorithms. So when we just call this function MLLGO, which is in the template, so you can see what happens. What happens here. So we can just we've already taken these values and we put those in the beginning of the PDF that we showed earlier. So in fact, now we are just having a regression problem. And in the regression problem, the boosting methodologies are giving us a better indicator of the GDP as compared to any other approach. And maybe the best competitor is the random forest. So I have uploaded all the data for this in this folder, which I will share. The link I will share in the YouTube video. Thanks for watching. And I hope that the students and the other practitioners can benefit from the templates that have been provided and continue to adopt this methodology for doing machine learning. Thanks a lot.